So I struggle at probability. It's probably one of my worst areas of maths, and I have taken way too long to answer this question. However, I particularly liked this question, and I wanted to do it um, in a video. So maybe if I do get asked a probability question, I have some of the verbal tools to cope with whatever I'm thrown in an actual interview. So the question is as follows. There is a zero point 0.5 probability that it will rain on a given day. What is the probability that during a week there will be consecutive rainy days? Now, I I thought about consecutive rainy days as as following. So, for instance, you have in a week you have 7 days, and I'm going to denote that with seven spaces or bars. Um, so, an example of a consecutive rainy day, if I say R is rainy and N is no rainy day. So RRRNRN is an example of a consecutive rainy days in a week. RRNNRR also counts, or RNRRNR also counts because of this. So this is my first conceptual level understanding of the problem. I want to find um, the probability that there has been consecutive rainy days somewhere in the week. However, as I've shown, there are multiple ways to calculate that, or at least to enumerate that, and that's going to take way too long. So the probability we're looking for is consecutive rainy days. Um, so usually when you are left with trying to find a probability which has lots of enumeration linked to it, you try to find its complement and you do 1 minus the complement. So, for instance, P of A is equal to 1 minus P of A prime, the complement of A, given that A and A complement are independent, which is always true. So I can turn this into 1 minus the probability that there are no consecutive rainy days. And an example of a non-consecutive rainy days is n, and so on. But I need to find how many of these are possible. So here is where I got stuck and I had to get a hint. And the hint was to kind of think of a reoccurrence formula. And I thought, okay, let's say my first day is a non-rainy day. For it to not be a non-consecutive rainy day, my second day must be a rainy day, or sorry, my robot's not working, or a rainy day or non-rainy day. If my first day is a rainy day, then necessarily my second day must be a non-rainy day, and then we have another string of R and N's that are valid. So if I use this concept, I hope it makes sense, and I say let A of N be a string of length N of valid Rn's and R's such that there are no consecutive R's. This is where the problem actually becomes quite fun because if I go with my first case, case one, first day is a rainy day, then I am left with n minus 1 spaces, or actually n minus 2 spaces, because I know this has to be an n. And my case 2, which is that my first day is a non-rainy day. So I have n, and whatever's after can be r or n, so on. So I have n minus 1 spaces left where I can put another valid sequence. So essentially, I know I'm explaining this awfully. an is equal to an minus 1 plus an minus 2. N minus 2 and n minus 1, sorry. So for instance, if I have n, here I can have an minus 1. If I have r, I know my second place must necessarily be n, and that is because if it wasn't r, then we would have a consecutive rainy day and therefore be going against the rule we set out. And here we would have an minus 2 spaces left, n minus 2 spaces left, where we can put a an minus 2 valid sequence. Now this is actually just Fibonacci. So we need to find a7 based on this rule, which is equal to a6 plus a5. Now I'm just going to list out the Fibonacci numbers. So 1, 1, 2, 3, 5, 8, 13. And I'm going to go down here. 21 and 34. And if I count, 1, 2, 3, 4, 5, 6, 7. I think we're starting from here. 1, 2, 3, 4, 5, 6, 7. A7 is 34. The reason we're not counting this is because we're starting our sequence with 2 as opposed to the 1s. Yeah. Because a sequence of 1 is R or N. A sequence of 2 is Rn, Nr, Nn, Rr, and so on. This is not really a sequence, this is. And so are all the rest. Now, we know that there are 34 non-consecutive strings. Well, actually, the better way to phrase this, 34 valid uh, length 7 strings. And now for any probability, I need the number of things we want over the number of things that are possible or like available. Actually, possible is perhaps not the better word. Total, what we want, and the total out of what we want. From what we want, sorry. So we know this is 34. So what are the all possible 7th length strings? It's going to be 2 to the 7, because if I draw this out, I have 2 options here, 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 7 places, so 2 to the 7 options. I have 2 options here because I can either have an R here or an N. This is why I'm saying there are two options. 2 to the 7. I should know what this is. I know 2 to the 6, it's going to be 64, so 128. 128, 34, and this can be simplified to what's that? 17 over 64? Yes. So again, I'm going to call this, let's say, star. So what we want is probability star. Um, Probability star is equal to 1 minus 17 over 64, which is 64 minus 17 over 64, which is uh, it's going to be 747. And this is my final probability. Now I am going to note that when I did this question, I didn't get it the first time round. I struggled a lot, and it's not because the question itself is hard, but it's more because I'm familiar with these kind of questions, and probability is one of those areas I genuinely and urgently I need to revise and improve at. So I'd very much appreciate if anyone has some recommendation of some like course I can binge watch or some like worksheet I can do to improve at this. But I did find this specific problem very cool, specifically because you can use recurrence relations and this Fibonacci thing. Because I was going to go down the route of actually listing all of them out, which is 34 is a relatively small number, so it's theoretically possible for me to list out all the possible ways, and eventually I probably would spot a pattern anyway somewhere. Perhaps I don't know. Perhaps I'm just um, overestimating my abilities. But the point that I'm trying to raise is that if you understand the question, or at least if you get the hints and you reach to a solution, then perhaps you have shown that you are capable of doing the question. Um, Now, what I'm going to do in the next few days is probably continue doing more and more um, probability statistics style questions. Not only because I'm starting to enjoy them, actually, maybe that's a lie, but it's more because I kind of need to know this kind of stuff. Probability is very important. I can't call myself a mathematician if if I can't understand statistics or probability. Yeah, I didn't think that doing this question was going to turn into a rant about the importance of probability, but um, stupid conversations aside, I think I'm going to end the video here. Thank you.